Okay, these are the problems that I picked that I thought were pretty much like some of the others. I didn't see a whole lot of different kinds. They can always make a simple, change to the way the problem is read or something, but I'm going to work each one. I'm going to go kind of quick because I kind of teach a class in about 20 minutes. Start off with this guy up here, problem number 4. Evaluate the expression. Alright, so what you're going to kind of do is you're going to try to use those properties of logarithms to maybe write this as a single logarithm so that you can get a value here. Now, as it turns out, we can do this without putting it all together. I know the minus means that you're going to divide and the numbers in front mean they're exponents. But if you just look at these are log base 4s, and this is 4 to a power, and this is 4 to a power. This is 3 times the log base 4 of 4 to the 3rd power. And this is 2 times the log base 4 of 4 to the 2nd power. Do you see how the bases of the exponent and the log match here and here? When you have log base b of b to the k, this is k. If these match, it's the exponent. So this right here, this is a 3. This right here is the exponent 3. Minus 2 times this right here is the exponent 2. Now if those don't match, then you got a little bit more work to do. So this turns out to be 9 minus 4, which is 5. Now here, they didn't put numbers, they put variables, so we're going to have to compress or condense using the properties of logarithms. I mentioned subtraction was division, addition is multiplication. But before I start multiplying, you see here and here, you have a constant in front. I'm going to bring it up using that third property, that third law of logarithms. Remember it says log base, b of m to the k is equal to k times log base b of m. It's like the exponent comes out in front where you can reverse it. You can bring it right back up. So this is going to be the log of t to the 3rd plus the log of u plus the log of v to the 3rd. Now because they're both addition and because multiplication is referred to here with the addition, I'm going to not do this in 2 steps. I'm going to do this all in 1 step. This is the log of t to the 3rd u v to the 3rd. That whole expression. There's not much you can do with that. It's kind of awkward looking, but that's it. You've condensed the expression. Now we'll reverse this. We're going to expand this single logarithm into sums and differences of logarithms. Now I have a product up top, but I'm dividing. The whole theme's a fraction. It's division. So it's the log of the numerator minus the log of the denominator. It's the log of x to the 3rd, y to the 3rd, minus the log of z to the 2nd. Now this product you can write as a sum of 2 logarithms. This is equal to the log of x to the 3rd plus the log of y to the 3rd, and then minus the rest. And then before I stop, I notice that all 3 have exponents. That's this property right here. I can bring the exponent in front. So this is 3 log of x plus 3 log of y minus 2 log of z. Oh, I put the equal signs on the other side. There we go. And there's my answer right here. My answer right here. Now, I hope I didn't mess this up. It says solve the equation. Well, when you have logs on both sides, what we want to do is we want to set the expressions that you're taking the log of equal. But this one's got a 3 in front. So same property, I'm going to bring the exponent up here. I'm going to write this as the log of 2x plus 109 equals the log of 5 to the 3rd power. So I have log of something equals log of something else. The two somethings must be equal. 2x plus 109 has to equal 5 to the 3rd, which is 125. I subtract 109 from both sides. I get 2x is equal to 16. I divide by 2. I get x is equal to 8. And I don't have any problem plugging 8 into there because that'll be a positive amount. So here's my answer. Now it says here, this is problem 13. That was problem 10. This one was 8. This one was 6. Here's problem 13, I think it is. It says John invests $2,200 in a company stock that decreases by 3% each year. Write a formula to represent the value V of t, the value of John's stock t years from now. Well, what you're going to do is you're going to put the investment, the original investment down, And then this part right here is going to be the base of an exponential function. And this base, because we are losing 3%, 100% minus 3% is 97%. So this base is going to be 0.97. You lose 3%, but you still have 97% of the original amount, and that's per year. So there's your equation right there. I used to write n equals n sub 0 b to the t over k. This was the original amount. This was the base of the exponent. If you were doubling or if you were halving, it would be represent that. K was the amount of time it took, and t was the number of years that went by. The number of times it took for, in this case, to lose 3%. So k would be 1, and that would just kind of disappear. All right, John invests $3,200 at 7% interest, compounded interest rate each year. Write a logarithmic expression that can be used to find t, the number of years needed to reach their goal of $9,000. So I'm going to go here with the amount is equal to $3,200 investment, 7% gain, so 100% plus 7 would be 1.07, 107%, and that's for each year. And I want to figure out for 9,000 years. So I'm going to plug 9,000 in, 9,000 years. $9,000, I want to plug that in for the amount. Sorry about that. 9,000 equals 3,200, 1.07 to t. Now it doesn't say find t, it just says write a logarithmic expression. So I'm solving for t. What I'm going to do is I'm going to divide both sides by 3,200. Would have been nice if it was 3,000, then you could come up with a nice simple number. But here I get 90 over 32, or 45/16 equals 1.07 to the t. Now I'm running out of space here, so I'm going to kind of move over to this side. I'm going to take the log of both sides. The log of 45 over 16 is equal to the log of 1.07 to the t. Then I'm using that property again. I'm bringing the exponent in front. And I have the log of 45/16 is equal to t times the log of 1.07. I'm solving for t. Get rid of this, what's multiplied times it on both sides. I'm going to divide both sides by the log of 1.07, and you see what t is equal to? Right there. And that is the log expression that he's asking for. Wow, that was a weird one. Okay, now you could get a calculator and actually find it, but they only wanted the log expression. Jump up to here. More compound interest, but not compounded yearly, compounded monthly. So you're going to use this formula. P is the principal, 1 plus your rate of interest divided by the number of times it's compounded in a year, raised to the n times t power, where n is the number of times it's compounded in a year, and t is the number of years. So we got $9,500, that's P. 1 plus, now our rate of interest is 6%. Don't put a 6 here. Change it to a decimal, 0.06, 6%. Slide it 2 places to the left. All over compounded monthly, so 12 times a year, every month, to the 12 times 10 power. 10 years. 12 times number of compoundings in a year, 10 times, or 10 years. So this is A equals 9,500. Now, I got to get Mr. Calculator busy here. So I'm going to put my paper down here for a second. I'm going to grab my calculator, and I'm going to take 0.06 divided by 12.005, add 1, 1.005, and then this is 100 or 120. So I'm going to raise that to the 120 power. Can you see that? Okay, now all of that turns out to be 1.819397 and some more. Now I'm going to multiply that times $9,500. And I get my amount to be $17,284, and to the nearest penny, 27 cents. To the nearest penny, 27 cents. Okay. One more to go here. You put a $10,000 into a bank account that pays 2.75% interest compounded, continuously. That's kind of what happens in nature with like populations. Find the amount of the account 10 years from now. Different formula. This is when it's compounded twice a year, 4 times a year, 12 times a year. This is compounded continuously. It looks like PERT. Principal times e to the RT, where e is the natural exponential base. It's about 2.718. So you got an E button on your calculator, we're going to use it. So the principal that you're investing is $10,000. E to the R is 2.75%, so that's 0.0275. When you change it to a decimal and drop the percent sign, times T, the number of years, and it's 10 years. So that would be 10,000. If I multiply these two numbers together, I get 0.275. See, it slides at 1 when you multiply by 10. 75. Now I gotta get my calculator busy. I've got an E button on mine. Oh, not that one though. I got an E button to the 0.275. I don't know if you've got one on your graphing calculator, you can find it on your scientific. I'm going to hit enter, and then I'm going to multiply this 10,000 times 1.31653 and so on. So times 10,000 gives me 13,165 to the nearest penny. Don't forget your dollar sign. $13,165.31. Now I went over those kind of quickly, but it's a little bit of each of the types. And of course you can always get some help from me later on. Give these a try and see how you do. I'll be happy to help you. You can give me a call.